Uh, okay, so then let's start. Okay, so please someone can confirm that my voice and this PPT is visible or not, and my voice is audible or not. Am I clear? And yeah, okay. So is it clear to everyone? Okay. So let's start the session. Okay. So my name is Devashish Ponda. I am a research scholar and a Prime Minister Research Fellow of Department of Civil Engineering at IIT Guwahati. So currently, uh, I am working on the modeling and identification and control part of the, large horizontal axis wind turbines in collaboration with Chalmers University, Sweden. Uh, so before joining that IIT Guwahati, so I worked as assistant professor under TechU3 project. Okay, so as all of you know that as a part of the PMRF duty, so we need to conduct extra classes or we need to take extra hours of teaching beyond the research work. So for this purpose, design of steel structure course. So I am allotted to this course and on every Monday, 7 to 9 p.m. Sorry, not 7:30 to 9:30. It's 7 to 9 p.m. So we will have the session. So during these 2 hours, what basically we do, we quickly go through the concepts that covered during that particular week. Then we solve the previous year assignments related to that particular week, and then we will open for the question answer session. Although during the whole session, the chat box is open for you to, if you have any kind of queries, you can put up there. I will, uh, try to answer them. Okay, so this is the second interactive session of design of steel structure. So on the last interaction session, during the last interaction session, we have gathered some information and knowledge about the steel structure. So I will come into it later. So today, what we will do basically, we will cover these topics. Um, then one second. Okay, we'll cover these topics. Then we'll solve the previous year assignments. So before going to the design part, so first topic of today is the design of the bearing type of bolts. So before going to that design part, let me quickly go through, some concepts what we have learned from the previous lecture. So most of you might be new. So during the first, interaction session, what we have learned about the steel structure. So first thing, the steel structures are made from the structural steel elements. These are made from the structural steel elements, and we have come across different kind of structural steel elements like I sections, channel sections, angle sections, and all the sections which are available. And we went through the specification of the sections also. We also come to know that as a designer, we need to more focus on the connections rather designing the element. On the RCC structure, on the other hand, when we will design the RCC structure, we have to design each and every element specifically. Then we went through that connections. First, we went through the riveted connections. So in riveted connections, what we have discussed, the basics of the rivet part, because our code IS 800 2007 doesn't include that rivet part. Also, during this course, most of the connections will be designed using bolt or weld. Okay. Then we went through the bolted joints or bolted connections, and we have learned some specification about the bolts. So I want to quickly cover that specifications of the bolt, because today what we are going to do, today we will design that connection. So before going to the design part, that basic parameters and basic, you know things should be clear. So let me quickly go through this section. So bolted connections, the connections which are made using the bolt as a fastener. So bolts, we all have seen the bolt. So bolt have basically two parts. One, where the threads are not there. Threads are not there. And another part where the threads are there. So this part where the thread is not there, we call it shank of the bolt. And the part which includes the thread portion. Why this thread portion are needed? Because to accommodate this nut. Okay. So this portion is called root or thread of the bolt. So obviously we can see that the two diameter will be different. So which diameter we call the diameter of the bolt? So we have already discussed that the shank diameter we call the diameter of the bolt. And the diameter of the bolts are generally denoted as like this M20, M22. That means we have a bolt whose diameter of the shank or the nominal diameter is 20 mm. Okay. So obviously if the dia will differ, then the cross section will be different. So the cross section here, the root cross section, we call the net area of the bolt A N B. We have denoted is like that, and the value of A and B will be 0.78 pi by 4 into d square, where d is the nominal diameter of the bolt. Shank, what will be the area of shank? ASB, it's nothing but pi by 4 into d square. So by this parameter or dia, we can understand what will be the diameter of the bolt. Then we have covered that how we can find out the strength of the bolt material. So obviously we have to design using that bolt, so we have to know the strength of the bolt material. So the strength of the bolt material we can find out from the grade or class of the bolt. Grade or class of the bolt. So grade and class of the bolt basically denoted by two digits, one before the decimal and one after the decimal. So before the decimal, that indicates the 100 of the ultimate tensile strength of the bolt. Say for example, we have 8.8 grade bolt. So this first 8 denotes the 100 of its ultimate tensile strength. So ultimate tensile strength FUB will be equals to 100 into 8, that will be 800 MPa. And this letter, or here we can this 0.8. So that denotes the ratio of the yield strength of the bolt FYB to FUB is equals to 0.8. So here we have calculated FUB. Now we can calculate FYB is equals to 0.8 into 800. So 640 ampere. So by this way, we can understand, or we can come to know if we have one bolt, then what will be the nominal dia, what will be the strength of this bolt, what will be the yield strength more specifically, and what will be the ultimate strength. Then what we have discussed during that last session, that how we can categorize these bolts. So basically we have categorized the bolts based on load transfer mechanism, because nothing if we need to make a connections or we need to make a joint, what should be first criteria that should be in our mind, that we need to transfer the load from one plate or one member to another member through that joint. So if here we consider that two plate and there is a bolt, and I need to transfer a one, say, sort of a shear force P through this joint. So basically, before going to design this bolt, first we have to understand how these bolts are transferring the load. So on the last session, I have discussed in detail how this load transfer mechanism is going to happen. So focus on this part. I will quickly go into this. So how? So for example, we have two plates. Okay, start from the beginning. We have two plates, one plate here, one plate here. So I need to make the joint using the bolts. So what I need to do first, I need to make a hole, right? So say for example, let's use another, we make a hole. So what should be that bolt hole diameter? D naught will be equals to D. that is the nominal diameter of bolt plus some clearance, and that clearance we will get from table 19. So we made the hole, then we put the bolt and tight the nut. Okay, the correction is made. Now in bearing type of bolts, that load transfer mechanism is happened, using the shear and bearing action. Now I will explain in detail why I am saying that shearing and bearing action. Through that shearing and bearing action, the bearing type of bolts are transferring the loads. Okay, so now think, I have made the joint here. For the bearing type of bolts, what I said on the last class, that we tight this nut up to snug tight condition. Snug tight condition mean up to that level of tightening that the member are firmly joined together. That means we are not introducing any kind of pretension to the bolt. Okay, now think, apply the load. So I have made the connections, now I am applying the load. So after some times, well, what will happen, the slip will occur and this part of the bolt this part will of the bolt will come contact with the plate, and eventually for this side, this part of the bolt will come contact with the plate, right? Yes or no? Obviously, when slip occurs, then the clearance will reduce, and these two parts specifically, this part and this part. So from this drawing you can see that if I pull this plate here from this side, so obviously this part will come in contact with the plate. Now when it come contact with the plate, what will happen? The bearing stress will induce. Bearing stress between the bolt hole and the bolt. So what will be that bearing stress? If we draw the cross section over here, if the diameter is d and the thickness is t, so the bearing stress will be P load upon the contact area, P by dt. That means the bolt will experience bearing in these spaces, and one more phenomena will occur. What will occur? If we watch carefully along this plane, what will happen? If we cut this bolt cross section here, so we will find one shear along the cross section of the bolt. So this plane we call the shear plane. Along the plane where the shear stresses are induced in the bolt, we call the shear plane. Shear plane. So shear plane. So across this plane, that bolt can shear off. So two phenomena are occurring: one bearing, one shearing. That's why the bearing type bolts will transfer the load using shearing and bearing action. So while designing this type of bolts, what we need to keep in our mind, that the bearing capacity and the shearing capacity of the bolt should be you know enough to withstand the applied load. Now come to that frictional type of bolt. How this frictional type of bolt transfer the load? So in frictional type of bolt, what we generally do, we introduce pretension to the bolt. That means we tighten the nut up to the certain level that an initial tension will induced in the bolt. So that tension, what that tension will cause? That tension will cause the compression between the plates. So Socho, think about it. If we tight the bolt, up to a level where some pretension is induced to the bolt, so what will happen? It will generate a compression between the plates. Now think, we are transferring the load P. What will happen? The friction will generate along these planes. The friction will generate along these planes. So in this type of frictional type of bolt, through that frictional action between the member, the load will transfer. Now the thing is, here I make that hole and I put the bolt within it. Now try to understand it. put the bolt within it. Now, when the slip occur, this frictional type bolt will act as bearing type of bolt, because until or unless the slip will not occur, this bolt will not get contact with the plate. So bearing and shearing action will not occur. So when we will design that frictional type of bolt, we will we will discuss this phenomena once again, when this frictional type of bolt will act as slip resistance, and when the slip we will consider. Okay, so that now we can get into the design part, how this design things will happen. Okay, so one more thing, before designing anything, what we are going to design here, we are going to design that joint, right? Particular joint. So if we want to design something precisely, or as a good designer, so we have to know the mode of failure of this product, or which I want to design. So here, that joint, think about it, the joint, either the joint, when this joint will fail, I make a joint, I am applying the load. When this joint will fail, when I consider this joint as a failure, when either this bolt can fail, or the plate, yes, the plates which are connected through the bolt, that can also fail. So this phenomena I already have discussed in detail during the first session. So failure of the bolt, we have to consider the shear failure, bearing failure, and tensile failure, because we are dealing with the bearing type of bolt, and we came across that bearing type of bolt transfer the load through shearing and bearing action. Now we have to keep in mind the failure of the plate. Now I will go to it quickly, that what should be the design procedure, what should be the assumptions using that designing using this type of bolts. So all these things. So first topic of today's lecture is the design of bearing type of bolt, how we can design these bolts. So basically we have some design assumptions, like, first, the friction. So we are designing using the bearing type of bolt, and the bearing type of bolt, what I said, that we tied that bolt up to the snug tight condition. That means we are avoiding the friction between the plates. So the friction between the plate is negligible. How we can achieve this assumption? Using that snug tight condition. Now second assumption, what is saying, the shear stress is uniform over the cross section of the bolt. Now this I will this is sometimes sort of that assumption we have to take in mind. Now uh, try to elaborate these things. The shear stress is uniform over the cross section of the bolt. Now I have put the bolt here, applying the load. So say for example I have put the bolt here and applying the load, and now I cut a cross section over here. Okay, now I am trying to find out what is the stress concentration over this cross sectional area. So what will be, where the stresses will be more, along the periphery, right? And when we move towards the center, the shear stresses will reduce. That means the shear stress is not uniform over the cross section of the bolt, but for the design purpose we have assumed that the shear stress is uniform over the cross section of the bolt. Otherwise we can, when we calculate the shear capacity of bolt and using that we will find the number of bolts, so then we will face trouble. Now third assumption is the distribution of stress on the plate between the bolt hole is uniform. Stress distribution between the bolt hole, say for example, let's consider this joint. So here I have bolt hole here and here, again here and here, maybe we can bolt hole here also if this joint is long joint. So this assumption says that within that bolt hole, whatever the stresses is generated, considered is as a uniform. But what happened, across this bolt hole the stresses are more, and when you move apart from this bolt circumference, the stresses will reduce. Now the fourth assumption is the bolt is subjected to bolts in a group subjected to direct load share the load equally. Now this is one of the most important uh, assumptions. Like if we have n number of bolts for this joint, if we have n number of bolts within that joint and I have applied the load P, then each bolt will carry the load is equals to P upon N. We have considered each bolt will carry or share the load equally. But this is also assumption, because obviously when the outside bolts will have experience more load rather the bolts which are located in the or towards the CG. Now the bending stress developed in the bolt is neglected because we are not considering the bending. Or bending, bending phenomena will less occur here. Think about it. The bolts are inserted in between that, so there will less chance of bending. So these are some basic assumptions of designing the bearing type of bolts. Now quickly come to how we can design it. Okay. So first we will visit the failure criteria again, like what I said or what we have came across, that the bolt can fail in shear, bearing, and tension. So we have to calculate the shear capacity of the bolt, bearing capacity of the bolt, and the tensile capacity of the bolt when the tension is directly applied. So we have seen that shear failure can occur, associated with different shear planes. Like when one shear plane is there, then we call it single shear failure. When two shear plane is there, we call it double shear failure, and so on. Now you can come to know why these shear planes are important during the design of the. So first thing we have to know about the bearing type of bolt is the shear capacity of the bolt. So the design shear capacity of the bolt, that is given on clause 10.3.3. So let's understand how we can calculate the design shear capacity of the bolt. So design shear capacity of the bolt is given by this equation, where let's try to understand each of the nomenclature separately. What is that FUB? What is that FUB? This is the ultimate tensile strength of bolt. From where we can get the ultimate tensile strength of bolt? From the grade of bolt. Say for example, if 4.6 grade bolt is provided, then we can find out the FUB. Now what is that gamma MB? That is the partial factor of safety for bolt. From where we can get the value? From the table 5. And what is the value of this? 1.25. Now come to this portion. Here the shear plane come into play. Here what we can say, A and B. We know that term A and B. What is that A and B? There is the net area or root area of the bolt. Now NN, come to this phenomena. What is that NN? NN means the number of shear plane passing through the root. Number of shear plane passing through the root. Now I will explain this phenomena. For example, let's consider these two plates. Okay, we need to lap them and through a bolt. So say for example, this I have put this bolt in here. So how many shear planes are there? Quickly tell me how many shear planes are there here. How many shear planes are there? There are one shear plane, right? So now think, if this bolt, say for example, the thread portion are up to this. So here we can see the shear plane is passing through this my shank portion. Or if say consider it's a full threaded bolt. So now I can consider the shear plane is passing through here. So that NN denotes the number of shear plane passing through the root. Now here the most important concept, the area of the root, that ANB is less than ASB. So obviously, which one will be the critical condition? The critical condition will be when my shear plane is passing through the root. Because when the shear plane is passing through the root, then what will be the shear stress develop? P upon तुम्हारा area. So area will reduce, that means stress will increase. So as a designer, we have to consider that the most critical condition, that is the shear plane is passing through the root. Now tell me here, how many shear planes are there for this? We have two shear planes. One is here one is here. So one may be passing through the shank and one may pass through the root. So come step by step. First, take this example and put the values over this equation. So for this example, how many shear planes are there? We have one shear plane. Now I can consider that the shear plane can pass through the shank or the shear plane pass through the root. So here NS, that denotes the number of shear plane passes through the shank. Okay, so what I will consider as a designer, I will consider that the shear plane will passes through the root, because that will be my most critical condition. Because when the shear plane is passes through the root, the shear stress induced in the bolt will be high. So for this case, if I consider these two plates, so the N will be 1, and what will be the value of NS? NS will be 0, because only one shear plane is there. So I can calculate the shear capacity. Now for this case, there are two shear planes. You can consider NN, one shear plane is passing through the root. You can consider one shear plane is passing through the shank. If in a question it is not specified where the shear plane is passing through, you can consider one of them. But as a designer, we have to consider the most critical condition, and that is we have to consider the shear plane is passing through the root. So what we have understood till now about the shear capacity, that the shear capacity is depend on the shear planes and the area. Obviously, what we are finding here is the shear force, how much shear force a bolt can carry. That means the stress into area. Stress, we are calculating the stress. That means we have know that stress, ultimate tensile stress, and the area we have calculated. So this part tells the shear capacity of a single bolt. Now here we have some correction factors. Okay, let me tell you one more thing. This is the screenshot of the IS 800, where here this is written FU. So instead of FU, you write it here FUB. That is the ultimate tensile strength of plate, is bolt. Ultimate tensile strength of bolt. Okay, and these parts, what I said, these parts beta Lj, beta Lg, and beta Pk, these are the reduction factor. So what that reduction factor will does, the reduction factor will minimize the capacity of the load, capacity of the bolt. So this I will come into that, the reduction factors one by one. So till now you have an idea that if I have a joint, and if I know the number of shear planes, I can calculate the shear capacity of single bolt. Now come to this uh, you know uh, correction factors part. What these correction factors tells. So first correction factor is the correction factor regarding long joints. Like, why these correction factors are introduced? Depending on the situations, the length of the joint, the grip length of the joint, even somewhere we have to provide the packing pads also. So depending on the situations, the design criteria may differ. So to counteract or to cater this type of situations, these three correction factors are introduced. So first correction factor or the reduction factor is for the long joints. So our code clause 3.3.1, so here is a screenshot of this code, says that if the length of the joint, LJ, so whom we call the length of the joint, किसको हम लोग length of the joint बोलेंगे? So it is the length from this to this we call LJ, length of the joint. So length of the joint. So for this joint, what will be the length of the joint? 50 plus 50. These are the pitch distances, and we have two end distances, 40 and 40. So we will have the length of the joint. We can calculate the length of the joint. So this code says if the length of the joint is greater than 15D, the D is the diameter of the bolt or diameter of the shank, then we call it a long joint. And if we have that kind of long joint, then we have to introduce one reduction factor or one correction factor, that is beta Lj. This thing. And the value of beta Lj, how we can calculate? We can calculate it like that. Beta Lj value will be this 0.175 minus Lj by 200d. What is that d? This is the diameter of the shank. And Lj, we can calculate the Lj if some joints are provided or we are designing some joints. So we have the pitch distances, we have the end distances, so we can easily find out the Lj. So if first thing, if my joint is a long joint, and when we call a joint is a long joint, when the length of the joint is more than 15 times of the diameter of the bolt, and then we have to reduce that shear capacity of single bolt. Now come to that second correction factor, beta Lg. That correction factor is for the large grip length. Now for example, try to understand, if I need to join 1 2 3 4 plates, or if I need to join, say for example, if I need to join two bigger plates, okay, say for example 50 mm and 50 mm, or more bigger plates. So what that grip length mean? The grip length mean the total thickness of the member which we are trying to connect using that bolt. Okay, so large grip length kab bolenge? When we call a joint having the large grip length, when this Lg, that the grip length. So how we can calculate the grip length? So here we have 50 mm and 50 mm plates. What will be the grip length? 50 plus 50, that means 100 mm. What will be the grip length of this? If I have 10 mm plate each, so it will be 40 mm. Okay, so if the code says if the grip length is greater than 5d, then we call as a large grip uh, large grip joint. And for this type of joints, we need to introduce one reduction factor, and that will be calculated using this equation, 8d by 3d plus Lg. What is that d? D is the diameter of the shank. Lg, that is the grip length. So I can, or we can easily calculate the grip length. How many plates are there or how many members are there? Just add the thicknesses, you can have the grip length. Okay, now one more reduction factor is there for the packing plates. Now when the packing plates is required, when we are trying to make a connection using butt joint, and there are two different thicknesses of plate. So to make the joint happen, we need to provide additional plate. Like here, say for example, here we have 20 mm plates and say for example 10 mm plates. And using that two plates, I need to make a double cover butt joint. So what I need to provide? A packing plates of thickness 10 mm. Right? Okay. So now one more most important criteria of the packing plate, that the packing plate doesn't carry any kind of load, or we consider that whatever packing plate we are provided, that packing plate will not contribute anything towards the load distribution. So why we need to provide them? We just need to provide them to make the connection happen. So socho, think if we don't provide the packing plate here, this 10 mm plate will move up and down if some reaction or if some vertical forces will come. So if what do you understand about the packing plates? That the packing plate will not contribute anything towards the load calculation or toward the load distribution or toward the load transfer mechanism. So if in some joints, or when this kind of packing plates may use during some joints, and if the thickness of the packing plate is more than 6 mm, so this clause says here, says if the thickness of the packing plate exceeds 6 mm, that means TPK. What is that? TPK is the thickness of packing plate that exceeds 6 mm. That means हम लोग 6 mm से ज़्यादा का packing plate को use कर रहे हैं, using the packing plate of 6 mm. So for this case, the shear capacity of the bolt should be reduced by this factor, and this factor says beta pk will be equals to 1 minus 0.0125 tpk. What is that tpk? The thickness of the packing plate. So here, say for example, I have used 10 mm packing plate. That means it is the thickness of the packing plate is more than 6 mm. So I need to introduce beta pk. So now what we have understood about the correction factors. The correction factors will multiply with the shear capacity of the bolt. And what you have understood or you have come across or you have noticed, have you noticed that all of the correction factors, are the value of the correction factors are less than 1, right? Less than 1. That means that correction factors are reducing the strength of the or the shear strength of the bolt. Okay, so for example, if there is no correction factor, there is nothing correction factor, we have a plain joint. So if in that joint, if the shear capacity of bolt is, let's say, 35 kilonewton, now I have introduced the correction factors. So that correction factors value will be less than 1, say 0.65, 0.78, like this. So what it does, it will reduce the strength of the bolt while designing. That means that's saying that you have, you know, uh, use long joint, large grip length or packing plates, then consider that your bolt will not take that much of load. Actually, the bolt can take, but for the design purpose, we will reduce the capacity of the bolt. Okay, so this all about the shear capacity of the bolt. Now, one more phenomena, the bearing type of bolt can fail. Tell me what can be that? What can be that? So how this bearing type of bolts will transfer the load? In shearing action and bearing action. We have understood the shear capacity of the bolt. Now we have to understand the bearing capacity of the bolt, right? So what will be the bearing capacity of the bolt? So till now, you have any doubt, query, anything? Am I audible? Am I audible? Or the phenomena like last week is happening? Yeah, can somebody confirm? Am I audible? Okay, okay, okay. And the screen? You can see the screen? Okay. So shear capacity, we have understood the shear capacity. Now come into the bearing capacity. So bearing capacity. So here the bearing failure, I have already discussed this during the last session. Now what will be the bearing capacity of the bolt? So the design bearing capacity clause 10.3.4 gives that the design bearing capacity of a single bolt is equals to 2.5 FU. What is that FU? That is the ultimate tensile strength of plate. Ultimate tensile strength of plate. So if I have or if we have FE 410, what will be that FU? 410 MPa. Now what is that KB? That is a factor which, you know, cater this pitch, edge and end distances. I will come into it later how we can calculate the KB value. D, that is the nominal diameter of the shank. T, now T, we have to understand what that T means. Okay, so first let's try to understand what that KB means. So it's a factor which cater the, you know, pitch distances, edge distances and end distances during the calculation of bearing capacity of bolt. So here the KB value we can find out minimum of, here these things are written, minimum of four things. One is E by 3 D naught, P by 3 D naught minus 0.25, FUB by FU and 1. That means that factor value should be less than 1. So what is that E? This is the end distance. What is that D naught? This is the whole diameter of the bolt. What is that P? That a pitch. So we have, you know, clear understanding about the edge, pitch and all these things. Now we have FUB, the ratio of the ultimate tensile strength of the bolt and the ratio of the ultimate tensile strength of the plate and 1. So by this way, we can calculate the value of KB. Now what is the T? T. code says T is the thickness or the minimum thickness of the plate experiencing the bearing on a same face. So let me go quickly go to this part. So for example, first try to understand with respect to a lap joint. So here we have two plates. Okay, say we have two plates. One is 10 mm thick, one is say 15 mm thick. Now I am applying the load. So this part will come into contact and this part will come into contact. Now for calculating the bearing stress, which thickness should I consider? Now here the load is same, but what happening here, the thickness is low. That means the cross sectional area will be low. That means there will be high bearing capacity or bearing stresses will induce. So which part will be more critical towards failure? This part, because the cross sectional area will be less, so more bearing stress will induce on that part. So for this type of joints where only two plates are there and two faces of bearing occurring, then we have to consider the minimum thickness of these two plates, because it is obvious that the smaller plate will fail in bearing faster, because that have less cross-sectional area. So which have less cross-sectional area, the stresses induced within that area will high. Now think where two or three bearing faces can occur. So come to this double cover bar joint part. So when we apply the load, what will happen? The main part will come into contact here and the cover part will come into contact here. So we have two different bearing faces, one on the main plate, which is acting on the opposite side, and these two parts of the cover plates, these are acting on the same side. So what will be my bearing stress, or what will be the T should I consider during that calculation of bearing stress? So that will be, so these two faces are on the same side, so we have to sum them. So summation of cover plate 1 and cover plate 2, and on the other side we have the main plate. So the thickness of T will be minimum of these two cover plates or the main plate, whichever is minimum. Now say for example I have two cover plates like 7 mm and 7 mm, and the main plate here is say 20 mm. So what will be the T value? T value will be minimum of 7 plus 7, that means 14, or 20, whichever is less. So what is less? That is 14, right? So here now you can understand what that T here written is. Summation of the thickness of the connected plate experiencing bearing stress in the same direction. Okay. So now one more phenomena I will give you. So we have same connections here, 20 mm main plate, and on the other side I have, say for example, 12 mm main plate and some packing plate are there. So one side main plate is 20 mm and one side main plate is 12. Tell me what will be the T? Tell me what will be the T? What will be the T? Sort of. Let me draw it quickly. So we have like 20 mm and we have another side two plates, 10 mm main plate and 10 mm packing plate. So 10 mm, and we have make the joint using double cover butt joint, and bolts are placed here. So what will be the T for this case? And the cover plates are like 7 mm and 7 mm. What will be the 10 mm? Very good, Varun. 10 mm, because this part, when we see the part here, the bearing will experience the main plate here, the bearing will experience, and two other faces here. And what I said, the pegging plate will not contribute anything towards the load calculation. So obviously the T will be minimum of 7 plus 7 and 10 mm. So what will be the less value? So the value will be 10 mm. So you now you have the clear understanding what T should we take during the calculation of bearing capacity of boat. Okay, so bearing type of bolt, what we come across, the bearing type of bolt will uh, transfer the load through bearing and shearing action. Now we have calculated the bearing capacity of the bolt and the shearing capacity of the bolt. So now tell me, what will be the strength of the bolt? So if I have the bolt here, and say for example the shear capacity of bolt is say 35 kilonewton and the bearing capacity of bolt is say 56 kilonewton, what will be the strength of the bolt? Strength of the bolt means the bolt, the amount of load the bolt can carry safely. What will be that? The minimum of these two, right? Right? Because if I increase the load beyond 35, what will happen? The bolt will fail in shear. So strength of bolt. Now we can understand how we can calculate the strength of the bolt. Okay. Now, what I said, a joint is made up with the plate and the bolt. So we have come across the uh, strength of the bolt. Now we have to understand the strength of the plate. Which kind of strength we have to consider for the plates? Because if the plate will fail, the joint will fail. So I have to, or we have to calculate the strength of the plate, or we have to consider the plate strength of the plate while designing this type of connections. Okay, so let's go quickly into that. Okay, before going to that, the tensile capacity of bolt, if bolts are directly subjected to tension, then we have to calculate the tensile capacity of the bolt. Tensile capacity of bolt is given on this clause. So when we will design the tension member using the bolt, we will discuss these equations, and these equations are very easy equations. What that tensile capacity of bolt, how we can calculate. So tension, when this bolt is subjected to direct tension, what will happen? It will try to elongate. So here the code says you consider the rupture here along the root, and you consider yielding here. Two basics formulas. So I will go through it when we will design the tension member more precisely. One more thing, when the bolt is subjected to direct tension and shear both, like for this connection, shear tension connection. So for these connections, we have to check one compatibility condition, and that says the shear factored shear force VSB, the factored shear force which is applied on the bolt divided by the shear capacity square plus the factored tensile force which is applied on the bolt divided by the design tensile capacity. Also this kind of this compatibility condition we have to check when we will design this kind of connection. So we will design this kind of connections in detail. So now for now skip these portions. So we quickly go to the design part. So till now what do we have understand about the bearing type of bolt? That bearing type of bolt will transfer the load in bearing and shearing action. We have calculated the bearing capacity of single bolt. We have calculated the bearing capacity of the single bolt. Now we know the what will be the strength of the bolt. Now what will happen to the plate? How we can calculate the plate strength? So here, mode of failure of the plate I have already discussed. The bearing failure of plate can occur. How? For that you have to visit the previous session, and the shear tear out. Now these two failures we can avoid. How we can avoid this? By providing adequate pitch and end distances. Okay, but more importantly, when we are talking about the bolted connections, that means we need to make a hole. So there is a probability or chances that rupture or yielding can occur. So we have to look into two main strengths. One is yielding. Now why this yielding and rupture is considered, that also have discussed clearly on the last class. So two strength of the plate we have to consider. First, the yielding of gross cross section. We have said that, or I have said that the yielding, the failure of yielding or too much yielding, we also fail as a, or we also consider as a failure. So that strength ड्यू टू यील्डिंग, यील्डिंग कब कंसिडर करेंगे? सॉलिड प्लेट के लिए, जब कोई होल नहीं है. जब होल होगा रप्चर को कंसिडर करेंगे. आता हो रप्चर में. सो क्लॉज 6.2 गिव्स यू द डिजाइन स्ट्रेंथ ड्यू टू यील्डिंग. दैट सेज TDG, the design strength due to yielding will be equals to AG Fy by gamma m naught. Now what is that AG? AG is the gross cross sectional area. Gross cross sectional area. What that means? If I have a plate like here and this is the thickness, width is B, thickness is T. What will be the gross cross-sectional area? B into T. Fy, it's the yield strength, because we are considering the yielding as a failure. So we have to consider the yield strength. Gamma m naught, that we also have discussed, that from the table 5 we can find out the factor of safety for the when we consider the yielding as a failure. So what will be the strength of a solid plate based on yielding? That we can calculate using this simple formula. Now we are talking about bolts. So obviously we need to make holes. That means the gross cross-sectional area will reduce. So what happened when we make the holes here? So for this, क्या होगा? So for example, say take a example, like we have a so what we can say, like we have a train ticket. You all have gone through the train tickets, right? So here we have that holes around two corners, right? Now if I want to tear it out, so easily this portion will tear apart. Why? The cross sectional area has reduced because of these holes. So if we reduce the cross sectional area, we have to consider the rupture phenomena, and the rupture phenomena we can find out from the clause 6.3, where that clause says that the TDN, that means the design strength due to rupture, and for the rupture, if you want to tear it out something, so it has to reach its ultimate strength, right? It has to reach its ultimate strength. So that's why we consider zero point 0.9 an, that is the net area. I will come into it. Fu, ultimate strength of the plate, but for the yielding, yield strength. To tear apart something, we need to reach up to the ultimate strength, and beyond that the tear apart phenomena can occur only. Now gamma ml, that is the partial factor of safety, we can find out from the table number 5. Now come to that an part. What is that an is the net effective area. So for example, if I look this section, say consider this is a plate of with 10 mm and thickness 5 mm. Now, if I cut this section here, what we can see, the cross section will look like this, gross cross section B into T. Now, if I make a hole here, what I am doing, I am reducing the area. How much I am reducing the area? If I make a one bolt here or one bolt hole here, I am reducing one whole area. So N will be the width minus number of bolt hole you have made within or along this width, into d naught. D naught, what is that? D naught, is the what is d naught? D naught is the diameter of the bolt hole. So by this way, we can calculate the net area of the plate, or net cross sectional area of the plate. So this net area, critical section, these things also will be covered in details when we will design the tension member. Now if the staggered pitching is there, then for the staggered pitching also code says that B minus ND0 plus, for the staggered part we have to consider some factors. Here this clause is given, that is summation of PSI. What is that PSI? That is the staggered pitch divided by 4 GI. G, what is that G? That is the gauge. So for this, so what we have, 1 2 3 staggered pitch. So here will be 3 into PS. What will be the value of PS? Whatever is prescribed in the question, or you can take it as a minimum, and 4 into G, that is the gauge distance. So by this way we can calculate the strength or the rupture strength of the plate. Okay, now so what we have understood, first, now consider this joint. We understand the capacity, shear capacity of the bolt, bearing capacity of the bolt. From that we can understand what will be the strength of the bolt. Strength of the bolt will be minimum of strength of the shear capacity and bearing capacity. Now what will be the strength of the joint? If I said what will be the strength of the joint, the joint is made up with bolt and the plate. So the strength of the joint will be minimum of the strength of the bolt. What is that? Minimum of shear capacity and bearing capacity, that is strength of the bolt. And this is strength of the plate. So strength of the plate, we have two kind of strength, like one is yielding and one is rupture. So the more critical phenomena is rupture during when we consider the bolted joints or bolted connections. So you have to consider the rupture strength. So if I said that the strength of bolt is your 60 MPa and strength of plate due to rupture is, say for example, uh, 62 MPa. Now tell me what will be the strength of the joint? Or if I said how much load this joint can transfer safely? 60. Okay. So Bhumi said 60, right? Because if we go beyond 60, what will happen? If we go beyond 60, what will happen? This bolt will fail, right? Okay. So strength of the bolt is a minimum of shear capacity and bearing capacity, because if one criteria will uh, exit or violated, then this we consider this as a failure. Plate, we have to consider two strength, and beyond this or among these two strength, the rupture strength is low. Obviously, uh, yielding for a solid plate, the strength of a solid plate will be obviously more than a plate where we make some holes. So strength of the joint. Strength of the joint. What will be the strength of the joint? Strength of the bolt and the strength of the plate. What will be the efficiency of the joint? So efficiency of the joint will be the strength of the joint. So how we can calculate the strength of the joint? The minimum of the strength of the bolt and strength of the plate. Strength of the solid plate. If the plate is solid, then what will be the strength? How we can calculate the plate of the solid plate? From clause 6.2. The strength due to yielding of gross cross section into 100. Okay. So, so now we have an idea that how we can calculate the strength of a bearing type bolt, how we can calculate the strength of a joint, or how much load a joint can transfer. Thirdly, what will be the efficiency of the joint, right? Now, we are in a position where we can solve some example. Yeah, we can find out the capacity of the bolt, we can find out the strength of a joint, or we can calculate how much load a joint can transfer safely, or we can calculate the efficiency of this joint. Okay, so let's quickly solve some examples. So till now you have any doubt or queries, you can ask me, or quickly we will solve some example, then we will go to frictional type bolts. So till now, is it clear what I try to say? So we are moving like step by step how this design thing will happen. So is it clear, or you are getting what I am trying to say? You know, yes or no? Okay, okay. So let's quickly solve. Okay, if you have understood that, yeah, you all have written that yes, you have understood that thing. So tell me one thing. Tell me one thing quickly. Okay, all of you quickly. So if for this joint, for these joints, okay. So I have a bolt whose shear capacity is 35 kilonewton. First, tell me how many shear planes are there for this joint. How many shear planes are there? Tell me quickly. One, right? So 35 kilonewton shear capacity, say bearing capacity 45 kilonewton. Yield, this is your shear capacity of bolt, this is your bearing capacity of bolt. Now come to the plate. So TDG is given as 250 kilonewton, and TDN is given as 250 is too much, say let's say 50 kilonewton. Okay, and TDN is say for example uh, 40. Okay, 40 kilonewton. Now tell me how much load this little joint can transfer. The bolt has shear capacity 35 kilonewton. The bolt has shear capacity, a bearing capacity 45 kilonewtons. The plate has the yield strength, or the strength due to yielding of gross cross section, that is 50 kilonewton. Now TDN we have 40 kilonewton. Now tell me, what will be the strength of the bolt? What will be the strength of the bolt? You can understand. Tell me one particular one thing. How much load I can safely transfer through this joint? How much load? Tell me. I have given some values. Tell me how much load? 35. Okay. Any more answers? 35. Good. Anyone? Obviously 35. Because first we need to calculate the strength of the bolt. So what will be the strength of the bolt? That will be 35 kilonewton. What will be the strength of the plate? That is 40 kilonewton. So what will be the strength of the joint? Minimum of the 35 and 40. Because when we, increase the load beyond 35 kilonewton, what will happen? What will happen? The bolt will fail in shear. Okay. So let's quickly solve some example. Like, okay. So, during this session, if we solve this example step by step on by pen and paper, so it will take a hell lot of time. So what I did, I solve them in a paper and add them. What I will do, I will share the handouts along with this PPT. So there you can have different kind of problems. Okay. So first problem, let us solve it quickly. What it says, find out the strength of the bolt, strength of the joint, and efficiency of the joint for this particular joint. Okay, where what is given here? The diameter of bolt is given here, the grade of bolt is given here, the plate strength is given here, and yield strength of the plate is given here, and the connection is shown here. So now try to understand the problem. You have a connection, you know the grade of bolt, you know the dia of bolt, you know the plates also, you know everything about the plate. Now you need to calculate the strength of the bolt, strength of the joint, and efficiency of the joint. So first, what I need to calculate? The shear capacity of bolt, then bearing capacity of bolt, then the rupture strength of the plate, then the yielding of cross section area, that due to that TDG we have to calculate, then we can find out the parameters. So whenever you have any kind of problems, first as a designer, write a section, given data, what data is provided. So if you think with respect to the designer, what designer have the data from particular site, the requirements, client requirements, cost requirements, all of these things. So first, make a column or make a section where the given data you can clearly mention. So what is given? The diameter of bolt is given. So write it down, diameter of the bolt is 20 mm. So when I know the diameter of the bolt and we are designing using the bearing type of bolt, so from table 19, what we can find out? The diameter of the bolt. So for 20 mm bolt, what will be the diameter of bolt hole? For the standard clearance, that is 2 mm. So for the bearing type of bolt, I already have explained, you have to go for the standard clearances, right? Now, what other things are given? The grade of bolt is given. So grade of bolt, from the grade of bolt, what we can find out? The ultimate tensile strength of the bolt. So what will be the ultimate tensile strength of the bolt? 4 into 100, 400 MP. Now the plate is also given, Fe410. So here we can find out the ultimate tensile strength of plate. Now from the arrangement, what we can see? So here this is 60 mm, this is 60 mm, and 30 mm, and here also 30 mm. So I will provide the handwritten notes also. Just understand or try to understand how we will design or how we will analyze this kind of joints. So pitch, obviously this distance, what is that distance? This is the center to center distance between two consecutive bolts measured along the direction of applied load. So this is P, I mean pitch. So we have written down the pitch. What is that distance? In distance, so 30 mm, and the thickness of the two plates are also given, that is 20 mm each. So that data we have. Now first we have to find out, and one more data we have. What? That we have, how many bolts are there? How many bolts are there? We have 6 bolts, right? So we have we understood how we can calculate the shear capacity of single bolt. So if I can calculate the shear capacity of single bolt, just multiply with that 6. So why we can multiply with that 6? Now remember that assumption. What that assumption said? That a group of bolts subjected to a direct shear, then the bolt will share the load equally. Okay. So first, what we need to do? We need to calculate the shear capacity of the bolt. So shear capacity कहाँ से मिलेगा shear capacity? We have already discussed from clause 10.3.3. We can get the shear capacity of the bolt. And for the shear capacity of the bolt, first look at the connections. Is there any kind of packing plate? Is there? No. That means we don't need to think about beta pk, the reduction factor due to the packing plate. Okay. Now think about, is the joint is a large grip length. So what is the grip length? 20 plus 20. That means 40 mm. And what is the diameter of the bolt? What? 20 mm, I think, right? So 20 into 5, that means 100 mm. So we don't need to think about the large grip length. Is my joint is large joint? Is it a large joint? Tell me, is it a large joint? What is the LJ, length of the joint? 30 plus 60 plus 30. That means 120 mm. So tell me, is it a large joint? Why we call a large joint? When that LJ is greater than 15D. Is it a large joint? No. So we don't need to think about any kind of correction factors. So we have a pure equation. FUB by gamma MB root 3 NN ANB NS ASB. Now tell me, how many planes are there? There is only one plane. So what should I consider? The plane is passing through the root or the plane is passing through the side? Because in our question, that is not mentioned that you should, take the plane is passing through that root or side. So root. Why root? Why root? Because this is the most critical condition. Okay. So here I have written that there is only one plane and we have considered that plane is passing through the side. So if only one plane is there and if the plane is passing through the shank, then what will be the value of this NN? 1, and this NS will be 0. So that part will eventually vanish. So only this part will contribute towards the calculation of shear capacity of the bolt. So what will be the shear capacity of single bolt? We can easily calculate. 400 is my ultimate tensile strength of the bolt. Already we have written it down. NN1 ANB 0.78 pi by 4 into d square. So that comes as 45.27 kilometer. So please go through the calculations. Maybe if there is any correction needed, so let me know. So what we have just calculated, this is the shear capacity of single bolt, right? Shear capacity of single bolt. Now here we have 6 bolts. When we call this joint, lap joint, as failure, when these 6 bolts will fail, or how much this bolt joint can carry, or how much these bolts will can carry the shear capacity, that the summation of the shear capacity of the bolt. So we have 6 bolts. So we have total shear capacity of the joint as 271 km. Now what do we need to find it out? We need to find it out the bearing capacity of the bolt. So for bearing capacity of the bolt, clause 10.3.3, we have the formula 2.5 kb dt fu by gamma mb. So we know the fu value. What is the value of fu? 410, because we have Fe 410 plates. What is the value of d? Diameter of the shank? 20 mm. What is the value of t here? We have only 2 plates, right? 20 mm and 20 mm. Here it is written 20 mm and 20 mm. So obviously 20 mm. Now what will be the value of kb? So kb we can calculate using E by 3d0. So what is the value of E? So I already told you, write down the given data. So here in a given data, that E value is provided, P value is provided. So we can easily calculate the value of kb. So kb comes as 0.45. Minimum of these 4 things. What is the minimum value of these 4 things? Beyond these 4 things, 0.45. So the value of kb is 0.45. Now put all these values in these equations. So we can calculate the bearing capacity of single bolt. Now what will be the bearing capacity of 6 bolts? Just multiply it with that. Now we can calculate the strength of bolts for this joint. What will be the strength of the bolts for this joint? For a single bolt, we can calculate. Now for the entire joint, what will be the strength of bolts? So it will be the minimum of shear capacity of 6 bolts or minimum of bearing capacity of 6 bolts. So here the shear capacity is less, and very often, or most of the cases, or for all of the cases, the shear capacity is less than the bearing capacity. So now we can understand what will be the strength of the bolts for this joint. It's 271 kilometer. Now we need to find out the strength of the joint. Strength of the joint. So we need to calculate the strength of the plate at rupture. So strength of the plate at rupture, from where we can get it? From clause 6.3.1. That says that TDN, that is the design strength due to rupture of critical section, is equals to 0.9 ANFU by gamma ml. Now calculate the AN. What is that AN? Net area. So we have two, sections where we made the holes, and two sections we have, symmetric sections. We have 3 holes here, 3 holes here. So we can calculate the uh, net cross sectional area, either 1 or 2 2. So what will be that net area? B, what is my B? 180 mm. So B minus N D naught. Remember flat sections, B minus N D naught into T. So B 180 mm, how many holes are there in a single section? 3. What is the diameter of bolt hole? 20 plus 2, 22. And what is the thickness? So this comes as the net area of the section. And if we put all these things, so gamma ml, go to table 5, you can find out the factor of safety. So that comes as 673 kilonewton. Now we can calculate the strength of the joint. So what will be the strength of the joint? The strength of the joint will be minimum of strength of bolts or strength of plate at rupture at critical section. So what will be that? 271 kilometers. So we have calculated the strength of the bolts for this joint. We have calculated the strength of the joint. Or if someone asks you what will be the value of load which that joint can transfer safely, this is the value of load which that joint can transfer safely. Now how we can calculate the efficiency of the joint? So to calculate the efficiency of the joint, we need to calculate one more thing. What will be the strength of solid plate? If I don't make any kind of folds, what will be the strength of the solid plate? So what will be the strength of the solid plate? We can get it from the clause 6.2. And that says TDG is equals to AGFY by gamma m naught. So AG for this section, what will be the AG? B equals to 180 mm, T equals to 20 mm. We don't make any holes here, or we don't consider hole to be here. So 20 into 180. So this is your AG part, this is your FY part, and this is the factor of safety for LD, 818. Now we can calculate the efficiency. What will be the efficiency of the joint? The efficiency of the joint will be the strength of the joint. So what is the strength of the joint? Minimum of strength of bolt or strength of plate at rupture, then strength of the solid plate into 100. So we can achieve 33% efficiency through that joint, whatever is provided to us. Okay, so by this way we can calculate the strength of the joint and efficiency of the joint. Now here I have added some more examples, like that was a lap joint. Now what will happen for the butt joint? So here I have a question. So till now for the previous example, I think you don't have any doubts. It's a simple example what we have discussed earlier. Now for the butt joint, what will be what parameter or what perspective will be different from the lap joint? For a lap joint, what I said, the joint will fail when this, say for example, if we have 6 bolts, so we consider the lap joint as a failure when these 6 bolts will fail. But for the butt joint, look at the joint, look at the joint. If either side, if this side will fail, what will happen? The joint will fail. If this side will fail, what will happen? Joint will fail. So for the butt joint, if the either side, one of the either side will fail, then we call the joint as failure. That means while calculating the strength and efficiency of that joint, we have to consider the bolts for only one side, only one side. And during designing that type of um, double cover bar joints, we need to consider that whatever the amount of bolt is coming, we need to provide that bolts on either side. We don't, or we can't divide them. We can't provide six. If the calculation says you need to provide 6 bolts, then we have to provide 6 bolts on either side, not 3 on this side, not 3 on this side. So now let quickly go through this example quickly. What is said? Find out the strength of the joint, efficiency of the joint. So strength of the joint, for calculating the strength of the joint, how much bolt should we consider? How much bolt should we consider? Or how many? Sorry, how many bolts should we consider for this joint? Tell me. 4, right? 4. So same kind of calculations. Same kind of calculations here also. First, calculate the shear capacity of bolt. We can calculate the shear capacity of bolt. So shear capacity of single bolt comes as 66.12. Now, one more thing is happening here. But here we have how many shear planes are there for this bar joint, double cover bar joint? How many shear planes are there? We have 2 shear planes, right? Here one and another one is here. So either we can consider that one shear plane is passing through the shank and one shear plane is passing through the root, or we can calculate that 2 shear planes are passing through the root to be in safer side. Or you know as a designer, we need to consider the most critical conditions always. So 2 shear planes are there. So here I have considered one passing through the root, one passing through the shank. So look, when we have single shear plane, the shear capacity was somewhere 35 to 40 kilonewton. Here the shear capacity will increase. So number of shear plane, if we can add the number of shear planes, the shear capacity of bolt will increase, because you know uh, the shear stresses will divide. So we calculate the shear capacity of 4 bolts. Now from the bearing capacity. Bearing capacity, we can calculate the KB, we can calculate the D. Now T. What will be the value of T? Quickly tell me, what is the value of T? If we can calculate the T value, you can easily calculate that design bearing capacity. क्या होगा T का वैल्यू? सो यहाँ पे देखो 2 कवर प्लेट्स है, इस साइड पे, इस साइड पे, इन दोनों पे बियरिंग होगा एंड इस साइड पे भी बियरिंग होगा. सो मिनिमम ऑफ 8 plus 8, 16 or 10. So what will be that? 10 mm. Very good. So you have now understood what will be the T value. So strength of this uh, bolt in bearing comes as 72. 4 bolts 28. So what will be the strength of bolts for this joint? Come as 264. Eventually, now we need to calculate the strength of the plate. Now tell me one thing. Um, for the rupture, we need to consider the main plate or the minimum thickness of the main plate. So here we have the plate. So we can calculate. Here we have 2 bolt holes. So n minus BD0. So by this way, the TDN value is coming like this, and we can calculate the yielding strength. So you just go through this and try to solve it, and we can find out the efficiency of the joint like 77.76%. Okay. Now I have added another example where I have used the packing plate. Now for this example, tell me, for this example, what will be the different thing rather than the previous example we have solved? What will what will be the different thing, or what will be the different parameter which we have to consider during calculating this joint? Tell me. First thing, when we calculate the shear capacity of bolt, we need to consider one reduction factor due to this packing plate, because the thickness of the packing plate is 8 mm, right? Second thing, one more thing is there. Here the main plate is 18 mm and 10 mm. So when you will consider the rupture thing, you have to consider that 10 mm plate, because just try to understand. You are pulling apart these 2 plates. Which plate will tear apart first? The smaller thickness one. Okay. So I will not go into it. So you can go through it. All these portions and calculations have added here. Now come to the design part. Up to this, what we have learned, how to calculate one section or design is given, from where you have to calculate the strength, efficiency. Now say you just have a load, you just have, you know, the grade of bolt, dia of bolt, and you need to design that connections. Like for these examples, for this example, what we have, you have to design a lap joint, a single cover butt joint, a double cover butt joint using what they have said, using yes, using 16 mm dia bolts and grade 4.6. So what we have to do in this design procedure, we don't have the number of bolts, we don't have, you know, that arrangement, what should be the pitch, what should be the edge, what should be the end. So what, or you know, what should we do for this kind of design? What should we do? First, we will calculate the shear capacity of single bolt. We will calculate the shear capacity of bearing capacity of single bolt. Now we will use that assumption that the bolts in a group subjected to a direct load will share the load equally. Okay, so we can calculate the number of bolts, then we will arrange it. So let's quickly you know, cover that lap joint portion. So I have, you know, added all this design part, but let's quickly come to that lap joint, how we can make a joint between these two plates. One is 18 mm and one is 10 mm using that 4.6 grade bolts. So we have to calculate all these things, how many bolts we require for this joint, what should be the pitch distances, what should be the edge distances, all these things. So first, given data, what is given? Diameter of bolt. From that, we can calculate the diameter of bolt hole. For the 16 mm dia bolt, the clearance will be 2 mm. Now, grade of bolt is given 4.6. So, if you B, we can calculate. Now, factored load is given also 150 kilonewton. That load we need to transfer to that joint. So, first, what we will do? We will calculate the shear capacity of a single bolt. So, how many shear planes are there? One shear plane are there. We are designing it. Now I'm considering that the critical condition, that the critical condition, that the shear plane is passing through the roof. So there will be one shear plane, NN will be 1, NS will be 0. My shear capacity of single bolt comes as 29 kilonewton. Here we are not using any kind of pegging plates. We are not using, you know, we need to think about the large joints or long grips, long joints and large grips. So simple 29 kilonewton. Now this is the shear capacity. We have to calculate the bearing capacity also. Now quickly calculate the bearing capacity. What will be the bearing capacity? So by this formula we can calculate the bearing capacity. Here we don't have, you know, what we don't have, the edge distances, end distances and pitch distances. So what we have to do here? We have to consider the minimum, whatever our code says. So what is the minimum pitch distance? 2.5. What is the minimum edge and end distance for the hand and flame cutted? 1.7 d naught and 1.5 d naught. So here for this calculation of KB, we have considered or assumed the value. Let's consider the pitch. That clause says the minimum pitch distance would be 2.5 d0. So here I have considered 40 mm. Now end distance. Here I have considered the critical condition 1.7 d naught. If someone says that we will consider the, you know, machine cutted or factory cutted sections, then you can go for 1.5 d naught also. So 31. Now we can calculate the bearing capacity. So I have shear capacity of single bolt, shear capacity of bearing capacity of single bolt. Now what will be the strength of single bolt? The strength of single bolt will be this. So how many bolts we will require? We need to transfer 150 kilonewton of load, and one bolt can carry 29 kilonewton of load. So how many bolts are there? Are required? 6 number of bolts. Okay, so 6 number of bolts. Let's say we will provide pitch 50 mm, edge and end 40 mm. So now we have all the data to make this joint. So now arrange the joint. So we have made the connections. We need 6 bolts. So we have arranged here like 2 in a row, here, 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 here. One, if someone says or someone want to provide that I want to provide 3 in a row and I want to provide 2 rows, he or she can provide it, but we need to check with respect to the strength of the bolt. So tell me, until now what we have calculated or what we have considered for the design, of this joint. We have designed this joint with respect to the bolt strength, right? We haven't considered the strength of the plate yet. So how we can consider the strength of the plate yet? When we have made the arrangements, now we have to check. We have to check for what? We have to check for that whatever we have, arrange, or whatever arrangement we have provided, is that arrangement is sufficient to withstand that TDN, or how is my rupture strength. So we have to check with respect to the plate, because until now we have designed that connections considering the strength of the bolt, not considering the strength of the plate. So now we have to check against the plate strength. So first we need to consider the TDN. So TDN we can calculate from this clause. So here I have provided 2 in a row. That means what will be my AN? B minus 2 into D naught. So this is my value of that TDN. So TDN value, what it comes? 484 kilonewton. That means that plate will tear out when the load will reach beyond 484 kilonewton. And how much load we need to transfer through this joint? Only 150 kilonewton. It's okay. So so for example मान लो कि if someone needs to provide that 6 bolts in a row. I want to provide in a one row and 6 bolt in a row. So he or she need to show that the design strength due to rupture is more than what the load need to be transferred. So clear how we can design and check the connections. It's for the lap joint. Now what will happen for the butt joint? Single cover butt joint. Only one thing will differ here. If we have calculated 6 number of bolts, then we need to provide that 6 number of bolts on either side. 6 number of bolts on either side. Why? Because if one of the side will fail, then we consider this as a failure. Okay. So now we have arranged this. One can say that I can provide 3 in a row. One can say that I can provide 2 in a row. You can just check that whatever you make or whatever arrangement you have made within that plate, that can sufficiently withstand the load whatever we need to transfer. Simply we need to check the value of the design strength due to rupture. So I think now till now you have an idea how we can design the joints. So what are the procedure of designing the joint? Designing any kind of joint. First, we need to calculate the strength of the bolt. Then using that design assumption that a group of bolts subjected to a direct load share the load equally, we will use that assumption and we calculate the number of bolts. Then after calculating the number of bolts, we will place as per pitch and edge end distances. Then what we need to do? We need to check against the plate strength. So till now, is it clear the design procedure? Now you will go through that note and try to make your own note. That thing will be more clear. So that philosophy and the thought process, how we can design it, I think this is clear. Yes or no? Tell me. So rest of the design is also here. So for the bearing type of bolts, is the concept is clear. How we can design it, or how we can calculate the strength and efficiency of a joint, all these things. So is that clear? Okay. So now quickly come to that design of frictional type of bolts. Okay, frictional type of bolts. So in frictional type of bolts, what we have seen that we introduce additional tension to the bolt so that additional compression force within that or generated within that plate, and when one shear force is applied, the friction will generate between that interlocking areas. So for that we have some dedicated code rather than IS 800. So this code we need for designing the high strength frictional grip bolts or frictional type of bolts. Okay, because these bolts are different kind of bolts, like we have different grade for them, the tightening method and all these things will differ from the bearing type of bolt. So IS 4000 along with 800, these two we need for the design of this kind of bolt. So let's go quickly what we have to do during this process. So what I said, or what we have understand regarding the frictional type of bolt, that we need to introduce some sort of additional tension. That means the bolt should carry that tension. So our code IS 4000 said the grade of bolts which we are or which we will going to use as a frictional type of bolts, the class of that bolt or grade of the bolt should be more than 8.8. Okay, 8.8. That means we are introducing high strength bolt. Why? If we don't introduce the high strength bolt, when we will introduce the tension, it will fail in tension only. Okay, so how we can identify the bolt? Identification. The code also gives some identification criteria. Like, someone give you this bolt. Now, but tell me, this is a high strength bolt or this is a bearing type of bolt. Say, for example, you went to a site and some steel work is going on. Some side or some execution engineer come and put two bolts in your hand. And, tell me what or which is the bearing type of bolt and which is the frictional type of bolt. So basically, the frictional type of bolts here in the head frictional type of bolt, that S is written 8S. That means the grade is 8 and it's a S means it's a high strength bolt, or we use that a frictional type of bolt. Okay, diameter, generally diameter we use 16 or more than 16 mm. Subsequently, for the nut also we need to go for high strength like 8.8, and nut also this mark of high strength bolt is also provided. Okay, now the thing is, the basic thing what we have understood about this kind of high strength frictional grip bolt is we need to add initial pretension. Now the first question comes, how much load or preload I can give to that bolt? How much preload I can give? So code says you can give a stress 0.7 if this we call the proof stress F naught. Or if we need to consider, or if we need to see with respect to the load, then the proof load should be 0.7 FUB ANB. What is that ANB? That's the net area of the 0.78 pi by 4 d square. So how much load we can give to that force? Preload 0.7 FUB ANB. So that much of load we cannot provide through the bare hand. So we have some tightening method, like turn of the nut tightening method, direct tension indicator tightening method, calibrated range method. So if you go through any standard book, you can find out this tightening method. Now let's quickly go to the design aspect using that high strength frictional grip bolts. So this high strength frictional grip bolt, using that high strength frictional grip bolts, we can design two kind of connections. One, when slip is restricted. That means we are avoiding that bearing and shearing action. And when this slip occurs, slip may occur. Okay, then what will happen? This frictional type bolt will act as shearing or normal bearing type bolt, which will transfer the load in shearing or bearing action. So two things can occur using that high strength frictional grip bolt. One, when the slip resistance is considered, and when the slip resistance is not considered. So we have basically two kind of high strength frictional grip bolt. One we call parallel shank type bolt, and one we call wasted shank type bolt. So in parallel shank type bolt, the area of shank is greater than area of root, the normal kind of bolt. But the wasted shank type bolt, here the root area is more. So this type of bolts are generally used when we design against the slip resistance design. Okay, so before going to designing these parts, so what will be the shear capacity of this type of bolts? So here clause 10.4.3 gives the shear capacity of the frictional type bolt. What it says, the shear capacity of the design shear capacity of frictional type bolt will be mu f, that is the friction between two plates. From where we can get the value from table 20. All the value of the frictional coefficient is given based on your requirements on the site. Any number of, what that says, number of effective interfaces offering the friction. That means if we have two plates, how many faces offering the friction? One. If we have butt joint, two. What is that? KH? That is a factor which catered the clearances. Like, what will be the value of KH for standard clearance? 1. What will be the value of KH for oversized clearance? 0.85. What should be the value of slot? 0.7. So oversized slot, that that concept also I have discussed on the last class. Now, what is that F naught? That is the proof load. Proof load, however, we can calculate 0.7 F UB A and B. Okay. So if we, and that gamma MF, that is the partial factor of safety. Yes. Partial factor of safety. So what I said, we can have two kind of connections, right? One, where the slip is restricted, and when slip can occur, then the bolt will act as a bearing type of bolt. So when the slip resistance at design at service load, then that gamma MF factor should be taken as 1.1, and when the slip resistance at design at ultimate load, then this gamma MF factor should be taken as 1.25. That means if we consider that up to the service load, yes, there will be no slip. If that load exceed the serviceability limit, then slip may occur. For this condition, we have to take 1.1. Now, find ultimate load. I'm designing, or I'm considering that until or unless the load will reaches the ultimate strength of the bolt, until then no slip will occur. That means slip resistance design. For this kind of design, we need to consider the factor of safety 1.25. Okay. So now we have all the data by which we can calculate the shear capacity of a high strength frictional grip bolt. Now, when we will design using that high strength frictional grip bolt, one more phenomena will occur. So that we call praying force. So before coming to that praying force, we will quickly go into that example. So I have here added one example. What I said, calculate the shear capacity of high strength frictional grip bolt of grade 8.8, 20 mm dia, standard clearances. All the data are given. Now two conditions I have given: slip resistance at design at service load, slip resistance design at ultimate load. The factor of coefficient for friction is given as 0.3. So how we can calculate it? Just calculate the shear capacity of the bolt. So shear capacity of bolt, that type of bolt, mu f Ne kh f naught divided by gamma mf. Gamma mf, that two value will differ. When we will design slip resistance design at service load, what will be the value of this gamma? 1 point. What is the value of gamma? 1 point. What it says? 1. So 1.1, and for this 1.5. So quickly calculate these portions. So here mu f already given. Any number of planes offering the friction. Now tell me, how many planes are there offering the friction? Here one plane is there, here one plane is there. 2. So we have 2 any. Cage standard clearance. So for the standard clearance, what will be the cage value? What the code says, the cage value 1. So now we can calculate that phi NSF, that means the nominal capacity. So nominal capacity I have calculated. Now we easily calculate the slip resistance at service load. For slip resistance at service load, what will be the factor of safety? 1.1, right? So this one. And so that is the shear capacity of single bolt. So how many bolts we will require? Total, the number of or the load which I need to transfer divided by the the capacity at service load. Now when we need to design at ultimate load, what do we need to do? We just need to change the factor of safety. So by this way we can calculate the shear capacity or the capacity of a high strength frictional grip bolts with respect to frictional coefficient, clearances, all these things. Now one more thing, yeah, uh, yes, someone has raised your hand. Yeah, you can put your question here. Tell me. Okay, so now just come quickly into that part, praying force. This is one of the important phenomena when we will design using the frictional type of bolt. So what happened when actually this phenomena will occur when tensile force is applied on these connections and connections are more rigid. So here we can see we make a connections through a plate and a T section is connected over here. Now think I am applying a tensile pull up to here. So here what happened? Obviously, if we have two bolts, the two bolts will equally carry that uh, half of that factor tensile load. Now, if we design that load using only this TE, that you know joint may fail because one more stress or one more force, tensile force, will generate through this or the uh, within that frictional kind of bolts. What is that? That is the praying force. Now try to understand the phenomena. Like when we apply the load here, the deflection will occur. So here it is showing large deflection. If we have little deflection, think about the little deflection. So what will happen? This portion of the plate will be suppressed and eventually it will exert a reaction force, and that reaction force will exert additional tensile force to the bolt Q. That Q is known as the praying force of the bolt. So praying force of the bolt is generally coming when we will design using the high strength frictional grip bolts, because high strength frictional grip bolt we have tightening uh, sort of like that it will not tear apart until it will reach the service or ultimate load. Now how we can calculate that praying force value? So we can calculate the praying force value. Our code says, our code given formula for that. So it says that Q is equals to LV by 2 LE T minus beta in naught F naught B T to the power 4. So I will come into that things like what is LV. This is the distance from the bolt center to the toe of the fillet weld or the half root radius of the section. Like this T section, whatever I am connecting here, this T section can be made using the weld. So we will quickly go into the weld portion, or it can be a rolled section. So if it is a weld that portion, then we have to go up to the root of the weld. What is the root of the weld? I will just come to it. What is that LE? That is nothing but the distance between center of the bolt to the end. That means it's nothing but the edge distance. So how we can calculate the LE? So to calculate the LE, there is also formula 1.1 T under root of beta F naught by Fi. What is that beta? It's a parameter, depends on if we are applying pretension to the bolt or not. So the beta value here, beta is 2 for pretension bolt, beta is 1 for beta is 2 for non-pretension bolt, and beta is 1 for pretension bolt. If not, that is the proof stress. So when we will go into a design problem or a problem statement, then we can understand these things quickly. Okay, so here I have added one example here. So I will come into that example little later, because when we will solve the assignments, there are also similar kind of problem is there. So before that, we have another topic, that is the welded connection. So we have to go through it quickly, then only we can go to the problem solving session. So till now you have some idea about the frictional type of bolt. I will share some notes and I will spend more time on that frictional type of bolt on the subsequent lectures. So till now you have some idea like what is the difference between bearing type and frictional type bolt, what should be the design consideration we have to consider while designing this type of bolts, and all these things. Okay, so now we have a understanding how a bolted joint can be made, what will be the strength of a bolt joint, what will be the efficiency of a bolt joint, how we can design a bolt joint. Now come to the another kind of connections that we call the welded connections. Why we need the weld connection? Because like till now we have understood about the bolt, we have learned how this bolted connection are designed. So why we need another kind of design, why we need to study another kind of connections, right? It's a basic question of a designer or a student So first let's try to understand what sort of advantages that weld connection can give us or can give over the bolted connection. So bolted connections where the bolts are used as a fastener, welded connection where welding is used. Now what is the welding process? Is a process by which we can connect the material to metals by application of heat with or without pressure. So we all have come across the welding process. So think like a design engineer. What are the basic differences? Like for the bolts, we need to make the holes, right? That means we are reducing the cross-sectional area. That means we are reducing the strength of the plate. Here, we don't need to make any kind of holes. That means we can transfer more load through these joints. Secondly, for the bolted joint, we need that cover plates, packing plates, all these things. So, uh, so yeah, I will come into your questions when the question answer session will be there. Okay, so keep your questions with you. I will be there. What is the significance? What is the role? I will give you everything. Yeah, wait. So here, what we have? Additional packing plates, additional uh, um, you know that cover plates, brackets, all these things we need to provide. So it will eventually reduce when we will design the welded connection. It will reduce the weight. Third thing, third thing is we can have better efficiency in welded joint because here the strength of the joint we can achieve up to 100%. Like we are welding two plates. If the parent material and the deposit material have the same strength, so we can make the plate as a uniform plate. So the strength, we can achieve more strength. Aesthetic look at this connection. Yeah, this is looks good, but how this connection is look like, it's a bulky kind of connection. So we have some aesthetic look. So now we can understand we have some advantages of that welded connection over this bolted connections, right? So here basically the advantages of the bolted connections are given. So we have some disadvantages also, like welded joints are brittle joints. We are depositing some material within the parent material. Obviously that joint will more brittle rather than the parent material. So the ductility, the uniformity of the ductility will vary throughout the section. Now uneven heating. So during that process of welding, we have to heat the portion. We need to deposit that reinforcements as a deposit material. So what will happen? There may be chances of uneven heating and cooling. One residual stress can occur, so that can lead to some failure, or we need skilled manpower. It's very difficult to check whether there are any kind of faults like internal pockets, air pockets left in within that joints or not. So we have some sort of advantages. Like we have advantages, we don't need to make holes. So eventually we can transfer more load, efficiency will more. We can make any safe. This is also important point. We can make any kind of shapes using that welded joint, right? So to make a bolted joint, we need if either we need to lap it or we need to place it face to face and make a joint. Here we can make any kind of joints using that kind of welds. So yes, now we have essence like why we need that kind of connections too. So we have basically two kinds of welds. One we call fillet weld, depending on their formation. Fine, we call a weld as fillet weld. Fine, we need to join the plate in a lap position, or we need to lap the plate and join them through welding, and then we call it's a fillet weld. Or we need to join two plates, like we need to join this to this. So if we need to make some joints within some angle, so the weld they are used, we call it a fillet weld. So today we will come across this fillet weld part and design part. Butt weld, what is butt weld? When we need to place two pairs face to face, then we need to connect them, we call the butt joint. So butt weld we will cover it on the next class. So today we will only go into the fillet weld part. Now we have slot and plug welds. So slot and plug weld, slot weld basically type of fillet weld. Fine, we don't have the available length, so we'll make some slots and we provide the uh, weld material here. So we will design all these things: slot weld, plug weld, butt weld. So today just stick into the fillet weld. So fillet weld, design of fillet weld. What I said about fillet weld, fine, we need to lap two plates and connect them using weld. We have to go for the fillet weld, or if we need to connect two plates with some angle, we will go for the fillet weld. Now, how we can calculate the strength of the fillet weld? What should be the size of the fillet weld? How we can design using that fillet weld? All these questions comes into our mind. So first thing, what should be the size of the weld? Size of this fillet weld. So size of the fillet weld, that is specified by the minimum leg length. So what we call a leg length? Leg length we call it is the distance from the these two parts is called the toe. Toe of the what? Toe of the weld, fillet weld. And this part, end of this part is called the root. So the distance between root to toe is called the leg. And the size of the weld is specified the minimum leg length. What should be the minimum leg length? So for this purpose, our code says what should be the minimum size of the fillet weld and what should be the maximum size of fillet weld. So the minimum size of the fillet weld depend upon the thickness of thicker part. Thickness of thicker part. Say for example, we have two plates. One 25 mm and another is 20 mm. Okay. Now we need to make the weld. So what should be the size? Minimum size. That minimum size depends on the thickness of thicker part. Thicker part. So what says? If the thickness of thicker part is up to 10 mm, the minimum size of weld should be 3 mm. If thickness of the thicker part is between 10 to 20 mm, the minimum size of weld will be 5 mm. When the thickness of thicker part is 32 to 50 mm, then 8 mm. So this will be the thickness of thicker part. One more thing, here said that if the minimum size of the weld is more than the thickness of thinner part, then the thinner part will be considered as the minimum thickness of the weld. Okay, so this is the minimum. What should be the maximum thickness of the weld? So for that also our code give some provisions. So if we need to make a joint between two plates, okay, two square plates, if we have two square plates, so the maximum size of the fillet weld should be the thickness of thinner plate minus 1.5. So if we need to make the connections between two plates, one is 10 mm, one is 20 mm. So what will be the maximum size of fillet weld here? Tell me. 10 minus 1.5. So 8.5 mm. Okay. Now for this angle section, when we need to connect a plate with an angle, so what will be for this section, for the angle section, what will be the maximum size of the fillet weld? That is the 3/4 of the nominal thickness of the angle section. For example, if we have a angle section ISA, say 40 into 40 into say 8 mm. So what will be the maximum size of the fillet weld? What? So 3/4 of 8. So 6 mm. So now we can calculate, like we can understand like how we can calculate the minimum and maximum size of the weld. Here one more important clause is given, like if we have deep penetrated weld, like submerged arc welding, when we have deep penetrated weld, for these cases we need to consider the leg size, matlab size of the weld should be leg size plus 2.5. That means in a deep penetrated weld, what will happen, the root portion will embedded here. So leg length plus 2.5, 2.4. So here SAW, submerged arc welding, it's a example of deep penetrated weld. When you will encounter the problems regarding submerged arc welding, you have to consider the size of weld is equals to the specific size of the weld or leg length plus 2.5, that 2.5 extra due to the deep penetration. Okay, now what should be the throat thickness? Throat thickness किसको पहले throat thickness बोलते हैं? It is the distance from the, what is that called, root, and the toe or the hypotenuse joining the two. So it is that distance. This distance is very much important because using that throat thickness, the effective area of the weld is calculated. So the throat thickness for the 90-degree angle we can easily calculate using the triangular and Pythagoras theorem, that it comes as 0.707 s. S is the size of the weld. So basically in general case we have the throat thickness is equals to K. It's a factor, depends on the angle between fusion phase. Like we have this plate and this plate. What is the angle between this fusion phase? 90 degree. If this angle is not 90 degree, what will be that value of K? If 90 degree, we can easily calculate what will be that throat thickness. If not 90 degree, what will we take that K value? So for this also our code says, here we have the table where these K values are provided based on the angle between the fusion faces. So 60 to 90 is 0.7 and so on. So if the size of the weld, if you know the size of the weld, if you know the angle between the fusion faces, you can calculate the throat thickness. Now throat thickness. Now come one more important parameter, the effective length, because the effective area of the weld is specified by two factors. One is the throat thickness and one is the effective length. So what is the effective length? Effective length we call the length up to which the effective throat thickness is maintained. Up to which the effective throat thickness is maintained. So here we call the effective length overall length minus 2s, or overall length we can say effective length plus 2s. Now what is that 2s? 2s, I will come to that. That is called the end return. Whenever we will terminate some weld, like we have a gusset and we have plate. Now we made weld here and here, right? So for this purpose, we need to terminate this weld up to a certain limit, so that we have some quality termination, or we don't have that warping effect due to the torsion. So for this purpose, code says that we need to you know extend the weld up to 2 into size of the weld as a end return. So here we have to provide, wherever we have terminated the weld, according the edges we have to provide 2 into size of the weld as a end return. Why? To have the quality termination, to have the additional forces which will counteract the torsional part. Okay, now one more thing, overlap length. For the bolted joint, we don't need to have any kind of minimum lap length or all these things. But for this case, what that code says, the overlap length of the joint should not be less than 4 times of the thickness of thinner part, or 40 mm. That means the lap length is should be equals to maximum. So this is the minimum lap length should be maximum of 4 times the thickness of the thinner plate, 40 or 40 mm. So we need to you know uh, cautious about providing when we are lapping two members each other using the weld connection. We need to ensure that the minimum lap length should be maximum of these two, and T is the thickness of the thinner plate. Now we have understood that, yeah, fillet weld have some parameters like effective length and throat thickness. So that two parameter, if we multiply these two parameter, that will give the effective area of this weld. So how we can calculate the design strength of the fillet weld? So the design strength of the fillet weld we can calculate from the clause 10.5.7, where it is given LW, that is the effective length of the weld. What is the T, throat thickness of the weld? So this entire part is the effective area of the weld. Now what is that FU? FU is the ultimate tensile strength of the weld, and this should be equals to minimum of strength of plate or strength of the material, that weld material we are depositing, the weld material, whatever is less. Now gamma MW is a factor of safety, 1.25 for shop welding and 1.5 for site welding. Table 5 will give you all the details. So using this equation, we can calculate the strength of a fillet weld per meter length. Now we can easily design, or we can easily find out what should be the strength of a joint, what should be the required length to connect using fillet weld. So let's quickly go through one example. Okay, like yes, we have one more factor here, like while we designing the bolted connection, we have some reduction factors like long joints, large grips, and all these things. Here for the long joints they have given one reduction factor, and that call that the beta lj value should be equals to 1.2 lj by Te. What is that lj? We have already know that the length of the joint. What is the Te, effective throat thickness, and the value will be less than 1. So when we calculate this thing, and when my joints, the element joint is greater than 15 tt, then we need to consider that beta lw factor. So most of the cases, as a designer, or most of the cases, these factors are eliminated at the first stage of the design. But if someone asks you in a question that what should be the reduction factor, so this is the reduction factor as per clause 10.5.7.3. So quickly, solve this example. Quickly solve this example. What this example says: design a suitable longitudinal fillet weld between two plates. We have two plates. One is 116 to 12 mm. That means the width of this plate is 160 mm and the thickness of the plate is 12 mm. Another plate 100 mm into 12 mm. So we have two plates. We need to lap them and we need to join them using the fillet weld. Where what said, lap and transferred a pull equal to full strength of the molars plate. So we need to design this connection for a full strength of the smaller plate. So how we can get the full strength? We know we have the clause 6.2. What says? That says the design strength due to yielding of gross cross section. So that is will be AgFy by gamma m naught. What will be that Ag for the smaller plate? 100 into 12. Fy, it is given here 250 MPa and 1.9. So we need to design this joint or this connection with respect to 272.727 kilonewton of load. So first, what we need to find it out? We need to find out the size of the weld. First, we need to find out the minimum size of the weld. So we have two plates, right? 12 mm thickness, 12 mm and 12 mm. So what we come across, that the minimum size of the weld depend on the thickness of thicker plates. So here we have two plates of 12 mm. So for 12 mm plates or up to 20 mm, the minimum size of the weld should be 5 mm. Now what should be the maximum size of the weld? Here we have weld between two plates. For the plates, what is the maximum size of the weld? Thickness of the thinner plate minus 1.5. So that comes as this. So we have a maximum size 10.5. We have the minimum size 5. What size should we consider? So let's consider 10 mm. Now here we can say, sir, I can consider 6 mm. Yes, you can consider 6 mm, but you need to provide more length. maybe you cannot accommodate that length within that thing. So you have a upper limit 10.5, you have a lower limit. So let's take, close to the upper limit 10. So what will be the throat thickness? Here we have two plates which need to be lapped, and here we need to weld them. So what will be the angle, fusion angle? 90 degree. For 90 degree, what will be the value of A? K, 0.7. So what will be the value of throat thickness? 0.7 into S. 7. Now, what will be the design strength of weld per meter? What will be the design strength of weld per meter? We need to calculate. From that, we can have the effective length. So here we have the equation like the design strength of the fillet weld is equals to Fu by root 3 gamma mw Lw into T. So here look, we have Fu, we have gamma mw, we have Te, throat thickness, but we don't have this length. How much length of weld should we provide? That portion we need to find it out. So how we can find out? We just equate that equation to how much load we need to transfer. So how much load we need to transfer? 272 kilonewton. So here is equals to 272.72 kilonewton. So from this equation, if we solve this equation, what we can find it out? We can find it out that Lw, required length of the weld, should be equals to this much. Now we need to provide it. So either we can provide on these two sides, or one more thing we can do, we can provide on this side. So these things are on our hand. Like first, let's try to understand, let's try to provide on these two sides. So what do we need to do? Nothing. We have, effective length 205. For the safer side, I have considered more effective length, say 210. So these two sides we need to provide. So how many lap lengths should I need to provide? 210 divided by 2, 105 mm. Okay. So what should be the actual length of the weld? So we need to provide the end return 2s here and 2s here. So what will be the actual length? La. What I need to say, side that you need to provide that actual length. Actual length will be 105 plus 2s for that side plus 105 plus 2s for this side. So that will be the total, actual length of the connection. Now, if someone need to weld this part also, so what do we need to do? It's a simple mathematics. First, one thing you need to understand how much lap, minimum lap you need to provide. So it says 40 or 4000 mm. So here we have 45 mm. So here I have provided 55 mm as a lap length. Here the width is 100 mm. So how much lap length do we need to provide? Total length we need to provide 210. Width of this smaller plate 100 mm divided by 2. That much of lap we need to provide. So is that lap is within the minimum criteria? Yes, we have find it out that the minimum lap length should be 48 mm. So this connection is well and good. So by this way we can design, or we can arrange one particular member using the welded connection. Now let's quickly come to the uh, question, previous year questions. So tell me, so you have understood something about welded connections, fillet weld, how we can design this fillet weld. So in the fillet weld part, three things is important: size of the weld, throat thickness, effective length. Then we have to consider the strength per meter. If we know the strength per meter length, we can easily design the welded joint. So we will, this weld part will continue, no problem. I will, explain one more example with this weld part. When we need to consider upper and lower portion, when we consider that end portion, all these things will be covered, no problem. So let's quickly today, due to the time constraint, um, uh, we have to stop our discussion regarding the topic. Now we need to solve the previous year questions. So let's quickly solve the previous year questions. Then we will, go for some question answer session. So first question: identify the joint shown in figure. What kind of joint is this? Tell me, which kind of joint is this? It's a double cover bar joint. C. Very good. Now, here what it says, two plates, thickness 32 mm. So two plates are there, 32 mm, 32 mm. Very good. Now we need to connect them through 12 mm diameter of bolt. Okay, here the diameter of bolt is said it's 12 mm. Now says calculate the reduction factor for large grip. So first thing, do we need that reduction factor? When we call a grip as a large grip, when our L, the grip length LG is greater than 5D. So here what is our LG value? 2 into 32. That means 64 mm. What is the value of 5D? 5 into 12, 60 mm. So yes, we need the reduction factor. Now calculate what will be the value of the reduction factor. So reduction factor, the value of reduction factor we can calculate from here, 8D upon 3D plus LG. Now quickly calculate. Uh, take out your calculators. So 8D. So I am writing here 8 into 12 divided by 3 into 12 plus LG. What is the value of LG? 60. So now tell me, sorry, 64. 64 LG. What will be the value of that? 0.96. One side 0.96. Please check. Is the value is coming as 0.96? Yes, we have a answer 0.96 over here. Okay. Is it coming 0.96? Yes or no? Yeah, one have answered yes, 0.96 is coming. Someone else? Just make this calculation. 8 into 12 divided by 3. Yes. Okay. Now move to the next question. Two plates 16 mm and 18 mm joined by lap using 20 mm dia bolt. So here also we have two plates, like one is 16 mm and one is 20 mm. 20 mm and one other is 16 mm. And we need to connect them using 20 mm dia bolts. 20 mm. Here they said the pitch distance is given, edge distance is given. Calculate the value of KB. Okay, we can calculate the KB. So what should be the value of KB? KB should be equals to minimum of E by 3 D naught, P by 3 D naught minus 0.25. Oh, okay, sorry. 16 and 18 mm plates are there. Sorry. 16 and 18 mm plates are there. 16 mm and 18 mm plates are there. Okay, no problem. FUB by FU and 1. So what is the value of E? Here E given as 35 by 3 into D naught. So we have 20 mm dia bolts. What will be the value of D naught? 22. So tell me what this value is coming? 0.5. 0. Tell me 0.53. I think. Now P by 3 D naught minus this. So P, what is the value of P? 55 mm divided by 3 into 22 minus 0.25. So how much it is coming? How much it is coming? Tell me. 0.58. Now FUB by FU, what is the FUB value? Here, okay, grade of bolt is not given, so we don't need to go that thing. So minimum of these two, what is that? 0.53. So 0.53 is our value. Okay. Now if that grade is also given, so if that grade is also given, then we can need to calculate that FUB by FU and 1 also. Okay. Now move to the next question. A high strength bolt may be used for, tell me. I have explained the high strength bolt. Now tell me, high strength bolt may be used for slip resistance connection and bearing type of connection. Fine, slip, you know, that thing, slip will occur. So both B and C. Okay. Now, if the ultimate stress in a fillet weld is 415 mm, grade of the weld, grade of the steel is Fe410, what should be the design strength? Yes, I also told you this parameter. What should be that Fu value? Fu value. Minimum of the strength of the parent material and strength of the deposit material. So here parent material, strength of the parent material Fe410, strength of the deposit material 415. So what will be that? 410 Newton per square. Clear? Okay. Now, what should be the maximum size of fillet weld used to connect a plate of thickness 10 mm? Tell me. I just told you. 10 mm thickness plate with a gusset plate 12 mm. So we have two plates. Plates. What is that? Thickness of thinner plate minus 1.5. So thickness of thinner plate 10 minus 1.5. How much it is coming? 8.5. Okay. So 8.5. Now here that thing I have added, you can go through it. Now praying force can be reduced by, okay, uh, decreasing the end distance, increasing the end distance, increasing the distance of the bolt from the hub of the root. What? So for this we need to, you know, understand this equation. So this equation is, did I so let's quickly go through that equation, okay, of that high strength bolts. Let quickly, so that we can understand which parameter we can reduce or increase to have this bolt. So here we have one length we called, okay, let me go to that slide. Here we called LE and LV. LE, that LE value. So that edge distances, like here, so here we can play that with that. Tell me, if we increase or decrease that end distances and edge distances, what will happen through this equation? Try to understand through this equation what phenomena will occur when we try to, you know, increase the end distance or when we decrease the end distance. What will occur? Is my praying force will increase or decrease? Say for example, if we want to increase the end distance, LE, we want to increase the L. What will happen if we increase the LE? The praying force will increase. Anyone? If we increase the, yes, it's inversely proportional. So tell me, what will happen in this phenomenon? If we increase the end distance, the praying force will subsequently reduce. So here we can see that praying force Q is inversely proportional to LV. And what is that? LE. And what is that LE? That is the end distance, or we can say edge distance. Edge, more specifically edge, because this distance is measured along the perpendicular direction of the applied load. So now go to that, you know, part, what that question says. So yeah, decreasing the end distance, no, increasing the end distance. So here only that B option will be correct. Yes or no? Yes or no? Is there any options which we can correct? Increase the distance of the bolt from the other? No. So only that portion, because this is the inversely proportional thing. Okay. Now next question here. Okay. These things I have also told you that if we have for the weld connection, if we have a long joint where the weld joint exceed 150 tt, 150 into thickness throat thickness, then we need to introduce one reduction factor, and that is this 1.2 lj by this. So this we have to introduce here. Okay, so basically what they are trying to, you know, find out here is that 1.2 and 2 factor you are, you know, remembering or not. But this kind of formulas, I think they will not ask in the exam, during exam, because you have the code right now. So they have asked. Now, one more question. Two plates of thickness 16 mm and 18 mm are joined using 5 mm weld. Okay, 5 mm weld. So S is equals to 5 mm. Fusion faces 105 degree. So what will be the throat thickness? K into S. So what will be that K value for 105, 100 to 105? 3.5. What said 3.5? So 100 to 106, we have 0.6. So if we calculate 0. What 0.6 into 5, so how much it is coming? 3, right? Okay, now yes, one more example is there. Like here, the frictional grip bolt problem is here. Now, what this problem says, an ISA 19 to 19 to 12 carrying a tensile force 120 kilonewton. Look, 120 kilonewton joined with 12 mm thick gusset plate with 18 mm diameter of HSFG bolt. So here, diameter of that high strength frictional grip bolt is 18 mm. Okay, grade of bolt is 8.8, so FUB will be 800 MPa. Okay, two things is given. One more thing, mu f is given. What is given? Mu f, is equals to 0.5. So 0.5 is given. What more thing is given? Ne, number of planes offering the friction, this is 1. What else is given? Anything else? Yeah, no slip is permitted, and we need to consider the standard clearances for this if the clearances is not given. So how can we calculate the number of bolts? So we have to calculate the shear capacity of bolt. No, what is the shear capacity of bolt formula for the frictional type of bolt? So for the frictional type of bolt, the shear capacity formula is this. So here mu f value is given. What is the value of mu f here? Tell me, what is the value of mu f given? 0.5 into any 1. What is the KH value? KH value 1 we will consider for the standard clearances, into what is the value of F naught? F naught will be 0.7 into FUB 800 into pi by 4 into AIF is 0.78, because we are calculating the A and B, into 18 square divided by we need to calculate that gamma mf. Gamma mf, two kind of partial factor of safety is here when slip is designed at service load and slip designed at the ultimate load. So in the question, what is provided? The slip is resistance at ultimate or service, when the slip is permitted. Okay, so we need to consider at the ultimate condition. That means this value will become 1.25. Now calculate and tell me what will be the value of this thing. So that will come in Newton. Tell me, what is the value that is coming? I think it's come as 44 point something, 44.46 किलो न्यूटन, और तुम लोग न्यूटन में निकाल रहे हो तो 10⁶ आएगा, 10⁻³ आएगा. So this amount of, shear capacity one frictional bolt can sustain. So now come to the question that how many bolts we will require to transfer, how much load we have to transfer the load. So does the load is given? Yeah, 120 kilonewton. So one bolt can carry 44.6 kilonewton of load. So how many bolts we required for transferring this load? 120 divided by that 44.46. So nearly that comes as 2 point something. So 3. So do we have the option 3? Yes. So by this way we can calculate the number of bolts. Okay. Okay, this that's all about the problem solving session. Okay. So yeah, I can understand that today we have crossed the time limit, but we had, you know, uh, a lot of topic to be covered. Even I have inserted some of more examples which I will provide to you. Okay. So now you can ask me if you have any questions, like anything. If you want to ask me, you can ask, or quickly